Hello everyone, greetings. Welcome to the course Mechanics of Road Vehicles. We are in the lane of CO number 3. Compare the characteristics of different types of governor. In our previous session, we have discussed about the objective of governor, construction and working of different categories of governors, classifications, terms that we are using to characterize the governor and the characteristics of watt governor, that is the relationship between speed and height of watt governor. Now we are about to analyze the characteristics of Porter and characteristics of Proel governor. We have discussed about the 6 terms that we are following. First, height of governor, radius of rotation, equilibrium speed, mean speed, equilibrium, maximum and minimum equilibrium speed, sleeve lift. The relationship between height and speed of watt governor is n squared equal to 895 divided by h. Here n indicates the rotational speed of spindle, h indicates the height of governor. N measures in RPM and h measured in meter. We are in unit number 3, control mechanism. We are going to learn about the characteristics of Porter governor. The notations to be used in Porter governor analysis are fly ball mass, small m mass of ball in kg, small w weight of ball in Newton, that is mass of ball into gravitational force. Caps M mass of dead weight in kg. Caps W weight of dead weight, that is equal to mass of dead weight, that is caps M into gravitational force. Omega angular velocity, which is measured in radians per second. Centrifugal force in Newton, which is equal to mr omega square. We know that omega equal to 2 pi n by 60. N indicates the rotational speed measured in RPM. The characteristics of Porter governor are the height and speed relationship of Porter governor. Even we have discussed about the construction of Porter governor in our previous session. We have to make it clear to analyze the characteristics here. As discussed in our previous session, the Porter governor is going to have a bevel gear at the base and the foundation may be here to attach the shaft, which we called spindle. The spindle is going to rotate based on the rotational speed of bevel and engine output. The spindle may have an upper point and lower point. The lower power points has 2 points. Upper arm and lower arm are fixed at the pivot points here. This upper arm makes alpha angle with central axis and lower arm makes beta angle here. It has 2 fly balls attached. The main difference between watt and Porter governor, that is pendulum type governor and loader type governor, difference is the central load will act at the sleeve portions. The central load may act on the sleeve portion. There we are going to attach the central load on the sleeve. This sleeve weight I take it as caps W. So that at the pivot point here I just take it as S1, S2. At S1 there will be a force caps W by 2. The total load or sleeve weight height on S1 and S2 will be equal. So I take it as S1 equal to W by 2 and S2 equal to W by 2. If spindle speed increases, the ball will move outward direction. If spindle speed decreases, I just take left side ball. If spindle speed decreases, the ball will move inward direction like this. We know that already discussed about this one. If the rotational available in any system, there will be some sort of centrifugal force will act on the system. And this governor has a height of h. For any analysis of any system, we have to make a free body diagram as discussed in our previous session. For analysis of the governor, I just take a fly ball separately. We can split the governor into two sides. This one is left side and this one is right side. These two sides are maintained at equilibrium. So for understanding, I just take any side for the analysis. I just take left side for our analysis to great understanding. Fly ball is taken for account. I just make it as point B because it is a ball point. And we have a pivot point on the top portion. This pivot point may be marked it as O as discussed in what governor. These 2 points are connected by one arm that we called upper arm, and we have lower pivot point here. So I just mark it as sleeve point or deadweight point. I just take it as point D. Now we make upper arm and lower arm. Upper arm makes angle of alpha with central axis. The governor height may be indicated as h. Lower arm makes beta angle as indicated here. Now we have to make a forces which acting on the ball and deadweight portions. Point B, O and D. Before that, the ball having a radius of rotation which is marked as R. We know that very well. If any linkages are fixed two sides, there will be some sort of tension will act on the linkage. So that if you take upper arm, there will be some sort of tension. I just take it as T1. If you look at it from ball side, the T1 will be in this direction because this one is fixed. If you pull this arm like this, it makes some sort of tension in this direction. If you look at it from point D, there will be some sort of tension like this. These two tensions are equal. I just make it T1. And if you look at it from ball point and lower arm makes a tension of T2 in this direction. If you look at it from point D, the T2 will be like this. These tensions are equal. And there will be some sort of centrifugal force will act in left hand direction, that is outward direction of spindle. I just take spindle speed increases, sleeve moves upward direction. I just take it in account. The ball has self weight in downward direction because of gravitational force. You know that very well. The ball weight I take it as small w. If you come to the total forces act on the ball is T1, T2, Fc and W. Four forces are acting on the ball. At the point O, there will be only one force act, that is tension. If you look at it point D, there will be a sleeve force may act at the point S1. I just take left side of governor for account so that the force act on the point S1 is W by 2. If you want to indicate, you just make it as S1 instead of D. That's our wish. So the force act on the S1 point is W by 2 and also T2 in this direction. Even for more clarification, I just take a upper portion separately and lower portion separately for easy understanding. I just mark a point B and O here. Just to take it as point B and point O. The arm makes alpha angle with central axis. Since you know that the angles are equal, the opposite angles are equal, so that if the angle here alpha means that here too it makes alpha angle. Now look at this point, it makes like triangle. Right? This becomes opposite side, it becomes adjacent side. Opposite, sorry, sine theta equal to opposite divided by hypotenuse. Cos theta equal to adjacent divided by hypotenuse. You know that very well. Here instead of theta we have alpha. Here too alpha. Opposite side is this one. Hypotenuse is here. Adjacent side is this is adjacent and hypotenuse is here. I just make clear sin alpha equal to opposite by hypotenuse. This one opposite, here hypotenuse. Cos alpha equal to adjacent by hypotenuse. This one is adjacent, this one is hypotenuse. Because alpha is, this line is opposite to alpha, so that it is opposite, it is adjacent. If you take this hypotenuse as T1, I just take hypotenuse as T1, so that opposite side is T1 into sin alpha. If you pull the arm like this, actually it moves in two axes. One is vertical axis, another one is horizontal axis. So that there will be two forces, vertical and horizontal forces will be there. If you pull the arm like this, it moves in vertical direction like this and horizontal direction like this. So two forces may act, vertical direction and horizontal force here. If you take this hypotenuse as T1, sin alpha equal to opposite divided by T1. So opposite equal to T1 into sin alpha. And here cos alpha equal to adjacent divided by hypotenuse. Hypotenuse is T1, so that adjacent equal to T1 into cos alpha. It is adjacent, I just make it as T1 cos alpha. It is opposite, I just make it as T1 sin alpha. Let us discuss about lower arm again. Here we have lower arm. This point I mark it as point B and here point S. At point B we have a tension of T2. The point B makes an angle of beta here. We know that opposite angles are equal, so that this one makes beta angle, means that here too it makes beta angle. If you look at it, it makes triangle like this. So that it is opposite side, this one is adjacent side, this is hypotenuse. I just mark here beta angle is here, so that this line is opposite, this is adjacent and here is hypotenuse. At the lower arm, T2 tension will act like this, so that the ball will move for account, a component will move like vertical direction and also in horizontal direction. Since the arm pull like this, so that it moves in vertical direction in downward and also horizontal direction like this one. So it makes two forces horizontal and vertical. Vertical in downward direction, horizontal in right hand direction. We know that sine, now take sine beta equal to opposite divided by hypotenuse. Hypotenuse is T2, so that sine beta into T2 equal to opposite. T2 sine beta equal to opposite. This is opposite side and this one is adjacent side. T2 cos beta equal to adjacent side. Now we splitted the T1 and T2 tensions into four forces. Two vertical forces, two horizontal forces. Two vertical forces are, I write here, T1 and T2 splitted into four forces. Two vertical forces are T1 cos alpha and T2 cos beta. T1 cos alpha in upward direction, T2 cos beta in downward direction. Two horizontal forces are T1 sin alpha and T2 sin beta. Sin alpha in right hand direction and T2 sin beta in right hand direction. These two are opposite, these two follow same direction. Now again we are going for point S. Point S makes T2 tension and W by 2 self weight. If you split the T2 tension, T2 cos beta will be in upward direction and T2 sin beta will be in left hand direction. As discussed in our first CO force analysis, if you want to analyze any system, any member, we have to first consider the two force member. Since there is no two force member in the system, then we have to go for three force member. The point S becomes a three force member. Here it gets three forces, that is two vertical forces T2 cos beta and caps W by 2, and one horizontal forces which is in left hand direction T2 sin beta. We just consider only left side of fly ball here. If you have another fly ball that is in right side, it makes also T2 sin beta in right hand direction like this, so that T2 sin beta will be neglected because there is no right hand direction forces here. This T2 sin beta is equilibrated by right hand or right side of governor. So I just make it as 0. T2 sin beta is neglected here, so that T2 cos beta must be equal to caps W by 2. We know that caps W equal to caps M into G, that is weight equal to mass into gravity. Since here we take it as weight as caps W, we just make a mass as caps M. Here T2 cos beta equal to caps W divided by 2, T2 equal to caps M into G divided by 2 cos beta. This is our equation number 1. Now we have calculated the tension acting on lower arm, which is T2 equal to sleeve mass into gravitational force divided by 2 cos beta. Now we are about to analyze the forces acting on fly ball. First force acting on the flyball is centrifugal force, which is in left hand direction, that is outward direction of spindle, marked as Fc. Self weight of the ball will be in downward direction, that is small w. Upper arm has T1, that is tension, lower arm has T2 tension. T1 tension resolved as T1 cos alpha in vertical direction, T1 sin alpha in right hand direction. T2 tension of lower arm is resolved as T2 cos beta in downward direction and T2 sin beta in horizontal right hand direction. If you resolve these forces, that is horizontal and vertical forces, we get a value of the relationship between speed and height of the Porter Governor. If you resolve the vertical forces first, there are three vertical forces acting on flyball, that is T1 cos alpha in upward direction, ball weight, and T2 cos beta in downward direction. I take upward direction force as positive, downward direction force as negative, so that T1 cos alpha is equal to T2 cos beta plus W. From equation 1, that is, we got T2 equal to mg divided by 2 cos beta, and we know that ball weight, ball mass into gravitational force. If you apply T2 and W values, so that we get T1 cos alpha is equal to mg divided by 2, that is mg divided by 2 cos beta. If you apply these two values in this, here we get T1 cos alpha equal to mg divided by 2 cos beta. Cos beta is cancelled, so that we get mg divided by 2, and weight of ball W equal to mg. We get a value of T1 cos alpha. Now resolve the forces of horizontal. We have three horizontal forces, that is T1 sin alpha plus T2 sin beta in right hand direction and Fc in left hand direction. I take right hand direction as positive, left hand direction as negative, so that T1 sin alpha plus T2 sin beta is equal to Fc. From equation number 1, we get mg divided by 2 cos beta equal to T2. If you apply this T2 value here, we get T1 sin alpha plus mg divided by 2 cos beta, that is caps mg into g divided by 2 cos beta into sin beta equal to Fc. T1 sin alpha plus mg divided by 2 sin beta by cos beta, you know that tan beta, which is equal to Fc. If you resolve this again, T1 sin alpha equal to Fc minus mg divided by 2 tan beta. These two sides are divided by, that is divided by T1 cos alpha. We get T1 sin alpha divided by T1 cos alpha equal to tan alpha, because T1 is cancelled. We get sin alpha divided by cos alpha equal to tan alpha equal to Fc minus mg by 2 tan beta whole divided by T1 cos alpha. T1 cos alpha value, if we referred, we get tan alpha equal to Fc minus mg by 2 tan beta divided by mg by 2 plus mg. The T1 cos alpha value we get is caps mg divided by 2 plus small mg. If you bring this divided term, this bottom term in left side, we get caps mg divided by 2 plus small mg into tan alpha equal to Fc minus mg divided by 2 into tan beta. If you bring tan alpha in right side, we get caps mg by 2 plus small mg equal to fc by tan alpha minus caps mg by 2 tan beta divided by tan alpha. Now take tan beta by tan alpha equal to q, and from the triangle we get tan alpha equal to r by h. Since it is a alpha angle, it makes this is a height, this one is r radius of rotation, so that tan alpha equal to opposite divided by adjacent. Opposite is r, adjacent is h, we get tan alpha equal to r by h. We know that centrifugal force equal to mr omega square. If you apply these values in this equation, we get caps mg divided by 2 plus small mg equal to fc equal to mr omega square. Instead of fc, we applied mr omega square here, and tan alpha equal to r by h, so that here if you apply r by h, the h will be in upside, so that mr omega square into h divided by r minus mg by 2. Instead of tan beta by tan alpha, we q. Just keep mr omega square value one side, other values are another side. So m omega square h, because r is cancelled, so we get m omega square h. Just bring this term this side, we get m omega square h equal to caps mg by 2 plus small mg plus caps mg by 2 into q. M omega square h equal to, again if you resolve this, we get small mg plus, just to take mg by 2 and mg by 2, it is a common term, we get mg by 2 into 1 plus q. We just resolve this term like this. Now we have to calculate the speed, that is rotational speed of spindle, that is related with height. So that I just keep omega square here, because omega equal to 2 pi n by 60, there n is rotational speed of component, and here we have governor height. I just bring height this side, that is from left to right, I just bring. Just keep omega square in left side, other terms just to bring to right side. We get mg plus caps mg by 2 into 1 plus q whole divided by small m into h. If you again resolve this, omega square equal to, I just brought g outside, small m plus caps m by 2 into 1 by q whole divided by m and into g by h. I just resolved this term like this. Now we know the omega equal to 2 pi n by 60 value. I just apply this 2 pi n by 60 value instead of omega, we get n squared equal to, apply all the value, because phi equal to 3.14, g equal to 9.81, I just keep n squared this side, we get n squared equal to, I just bring all the value right side, apply those values of g equal to 9.81, phi equal to 3.14, we get 895 divided by h into small m plus caps m by 2 into 1 by q whole divided by m. This is equation number 3. Now we just found the relationship between speed of Porter Governor to height of Porter Governor. The relationship between speed of Porter to height of Porter is indirectly proportional. Speed is measured in RPM, height is measured in meter, mass is measured in kg. Caps M indicates sleeve mass and small m indicates ball mass. Thanks for kind listening.